Hi there, Rachel Chase here, and in this video we are going to explore inferences we can make about populations based off of two samples. This might be two sample proportions, or it could be two sample means. So let's start by discussing when might you use two samples. Two samples are heavily used in practical application where you're trying to do a comparison between two different things that could occur, or trying to extrapolate on something you may already know a little bit about. Similar to what you may already know from one sample hypothesis testing are your different hypothesis test options. So let's take a look at how you could set these up as they pertain to two proportions. As you can see here, these are our three different setups. Similar to what you would have learned about in your one sample testing, these on the left indicate one-tail tests because they're directional. And of course this over here would be our two-tailed test. Now notice, because we're dealing with proportions, we're doing a comparison between the two different population proportions. Let's take a look at an example here. First thing we're going to take a look at is pulling out all of the information necessary here. Among 426 workers surveyed in a Gallup poll, 192 said that it was seriously unethical to monitor employee mail. Among 121 senior level managers, 40 said that it was seriously unethical to monitor employee email. Consider the claim that those saying that monitoring email is seriously unethical. The proportion of workers is the same as the proportion of managers. So in other words, we want to find out, is this roughly the same of the standard workers as it is to managers that believe monitoring email is considered unethical. So what we're going to do here is fill out what they tell us. Let's start with the Gallup poll information. We had 192 people say yes, it is unethical, out of a total of 426. So that means that our sample proportion here is equal to 192 out of 426. Similarly, we had 121 senior level managers surveyed, and 40 of them said that it was seriously unethical. So the sample proportion here is 40 out of 121. We want to test this claim at a significance level of 0.01, so go ahead and set up your null and alternative hypotheses. Our null hypothesis is that these two proportions are actually equal to one another, so that P1 is equal to P2. The alternative is asking us what exactly? We want to know, is the proportion of workers the same? So in other words, you're looking to see if there's been any change. So that would be a two-tailed test. What we're going to do here is use our calculator to acquire the test statistic as well as our p-value to make a decision. Now, keep in mind that there are formulas for this. However, for the sake of time and our understanding, our goal is to really learn what we can interpret from this. So using your graphing calculator, you're going to select Stat, Tests, and you'll see under your test menu we have a two-proportion z-test. We have two different proportions, both of which are sample proportions, so that is the correct option to select. Fill in the information that we know. And make sure that your test matches. We're doing a two-tailed test, so select this first one here. When you calculate, you can see a lot of information is provided to us. So what have we learned here? This is our z-test statistic. Again, you can get this using a formula, however, it is quite lengthy. This piece right here is our p-value. And you'll notice below that each of the sample proportions is given as an approximate. Well, in this case, our p-value of 0.089 is bigger than our alpha of 0.01. So we can say that we fail to reject our null hypothesis. In other words, the decision-making process is not changed from what we already know. So what does it mean for us to fail to reject the null hypothesis here? Well, because we're failing to reject the null hypothesis, we do not have sufficient evidence that there is any difference in our sample proportions. So in our population proportions, that is. In other words, if we extrapolated this on a bigger scale and we had looked at, maybe 1,000 general people and 1,000 managers, we would see that the samples end up being roughly the same. Now, what might that suggest? Although you can see here that this is about 42%, this one's about 33%, those numbers seem off, but in terms of statistics, they're not that far apart based on the results of our sample to indicate that there really has been a change. Again, if you tested this with a larger sample, you might find otherwise. However, this is backing up our thought that there really is no difference between what the general population thinks and what the managers think in this case. Let's go ahead and look at an additional problem here. In a study of police gunfire reports during a recent year, it was found that among 540 shots fired by the New York City police, 182 hit their targets, and among 283 shots fired by the LA police, 77 hit their targets. At a 0.05 significance level, test the claim that the NYC police and LA police have the same proportion of hits. So, same thing we did before, take a moment and fill in what we know. X1 is 182 hits, and N1 is of those 540 that the New York City police had shot. That means that our sample proportion is equal to 182 over 540. Similarly, X2 is 77 hits out of a total of 283 shots fired, and the sample proportion there is 77 over 283. So again, test at a 0.05 significance level. Go ahead and set up your null and alternative hypothesis. The null hypothesis is that these two proportions are the same. And in this case, they want to know if do we have evidence supporting that the proportion is the same. So in other words, we're going to test this as a two-tailed test to measure consistency here. Are these numbers the same or not? So in a way, it's if we can fail to reject our null hypothesis, we are showing what we had thought, that there really is no difference. So let's see. Again, using technology, you're going to go ahead and plug in what you know. And it's just coincidental that we're also using a two-tailed test for this. Keep in mind that's not always going to be the case. So what have we found here? We have found our p-value of 1.91, our z-score of 1.91. And our p-value of approximately 0.057. So if we compare, our p-value is greater than alpha, which means the same thing we had found before. We fail to reject the null hypothesis, which means we have insufficient evidence, or we do not have sufficient evidence, however you wish to say it, that there's any difference in their amounts. So again, what might this suggest? What's the big picture here? There's no evidence supporting that there's any difference in their population proportions. That concludes this video. In our next video of this series, we will take a look at testing with two sample means instead. See you there!